started. Okay, we just paused our video that we were watching at the phrase positional notation, okay? And as you know, because you're all very good with our base 10 system, we use a positional place value system to write our numbers, okay? So I'm going to write a couple of numbers on the whiteboard. So here's number 5, and here is 50, okay? I want you to take a moment and look at these numbers. Discuss with yourselves, how is this 5 different from that 5?
It's 10 times more. Yeah, 10 times.
Okay. What makes this 10 times more than this, though?
The zero.
Because it's where?
It's in the tens place.
It's in the tens place. So it is one place to the left of the 0. So because its place is different, its position is different, its value is different. Even though this 5 looks exactly like that 5, doesn't it? All we did was move it over one spot, and it went up 10 times, didn't it? Okay. Well, base 10 with manipulatives. Okay. When we count, we start at what? We start at 1. Okay. So because we're in a base 10 system, these are symbols, by the way. They're different from our numbers that we use. So this would be what? How many would that be? 5. That's 5, okay? There's 5. Okay. I know, they come from science. We'll make our observations on that later.
Yeah, it has a lot of conversation.
So this 5 would be representative of which 5 from our... The first one, because it's 5 ones, okay? Now, how would we represent this 5 with base 10?
5 tens.
5 tens, okay? So these would be the 50, right? Okay. Well, just like we have position in our numbers that we use, we also have symbols which relate to these positions in our base 10 system. And in the second lesson after this, we're going to talk about something called binary numbers, and you are going to devise a base 2 symbol for that system. But for right now, let's just research some other number systems. So this is our number system, right? Okay.
Does base 2 just sound weird to me because it's not like in our...
It is weird. It's going to be weird, but it's going to be fun. So we'll get there. So, how do we translate these base 10 models, though, to decimals? So we just correctly, this is 50, right? And this is 5. But once we start talking about decimal values, remember we've talked in class about decimals in base 10, what would this represent in decimals with base 10? Okay, so this would be a 0.5, right?
Yeah,
so this would denote a different position in the number, okay, if we're talking about decimal numbers or parts of a whole.
100.
And this would be
0.05.
0.05. Very good. All right. So here is what I'm going to let you do today.
You gotta keep stuck in there?
I do when I squished it because they're squishy. All right. So before we do it, though, I want you to just have some questions in your mind. So what are the pros and cons of our number system? I want you to think about that for a second. You can talk to your neighbors. You can talk amongst yourselves. But take 1 minute, and I want you to think about what are the pros, the good things, and the cons and the bad things of our number system, of this stuff.
I think the pros might be because it's easier to count with tens, these ones, because you can just count them easily with 1 and 2 like that.
Okay, and how would you count with this then?
You would go 10, 20, 40, 50.
Okay, so same concept as counting with the 1, 2, and the 3, except you're just putting a 0 behind it.
But if you were to count 50 with the ones, it would take a long time.
Yeah, take a long time.
But so it's easier to count by what?
Tens.
Tens if you're going to 50. Okay, so can we draw these things that we can touch? Yes, we can.
You can draw almost anything.
You can draw it as a what? Just a flat square.
Yeah.
Okay. How could we add using this?
You can use as the cubes as 1, and you can, like, if we know that's 100, we could add 10 more and add 100 plus 10.
Okay, so 100 plus 10 is 2.
Got 110.
Okay, So these are helpful. It's really helpful when you're little because you can move things around, right? But you guys are older, so you're more comfortable with these types of symbols, aren't you?
Yeah, but it's still easy.
It's still easy, and you can make the connection. Well, what I want you to do today is you're going to be researching other number systems, and it's going to be weird, okay? You know how easily you guys worked with base 10? It's because you've been taught it since when?
Kindergarten.
Remember calendar math? You're doing your bundles and all that good stuff. Well, what you're going to research today might be a little different, and it might be confusing, but I'm going to let you, I'll explain what you're doing. You're going to work in groups of 3, so go ahead and figure out which group of 3 is what.
It's Rihanna, me, and Karamia, then Cole. They want to do French with me.
Okay, so 3 and 3. All right, so someone pick a number between 1 and 10 in this group. Or this group, sorry.
5, 7.
Okay. 7. Okay, you guys pick a number.
She picked 4.
Okay, 4. The number was 10, so you guys were closer. So you're going to pick a number system that you're going to research.
No.
So who's picking?
I'll pick.
Oh wait, let's let Colvin because we chose it.
Well,
Can I pull up?
And he's the only boy in the group.
yeah. I forgot
That
what
was
we were
very
gonna do.
generous.
Just pick one.
Just pick one. Just pick one. Anyone.
Go ahead. There you go.
Which one?
Ladies, who's picking?
I am. What is it? I'm gonna go with this bottle.
Okay.
Is that too okay?
What number system do you have?
Babylonian.
Huh?
However you say it.
Babylonian.
Babylonian.
Roman numerals.
Okay. Guys, I'm going to put you on a timer and I'll stop the video, but you're going to have about 8 minutes to research those number systems. And you can use computers in the back. And then when you're done, you're going to come back and you're going to partner up with somebody from the other group and you're going to tell them about what you found out.
I have a question.